Hello everyone, I am Navaneeth studying Industrial Engineering 2023 batch of CET. Today we are going to discuss a problem based on the topic centrifugal pumps. Calculate the required power to drive a centrifugal pump which delivers 0.05 meter cube per second of water to a height of 15 meter through a 16 centimeter diameter pipe and of length 100 meter. The overall efficiency of the pump is 16% and the coefficient of friction F equal to 0.1 in the equation HF equal to 4FLV square divided by D into 2G. So let's go to the answer. Given height HS equal to HS plus HD, which is 15 meter. Discharge Q equal to 0.05 meter cube per second. The diameter of pipe D equal to 16 centimeter equal to 0.16 meter. The length L equal to 100 meter. The overall efficiency eta equal to 60%. The coefficient of friction F equal to 0.01. So let's take a look at this figure. Here we can see that the static discharge head, which is the HD of our equation of height. The equation of height H equal to HD plus HS. The HD here is the static discharge head and the static suction lift is the HS. So the total static head is the height of our centrifugal pump. Going to calculation, we have to find the velocity. The velocity of water in pipe equal to discharge divided by area of pipe equal to 0.05 divided by pi by 4 into diameter square. Diameter we have as 0.16. So by calculation we get the answer velocity equal to 2.49 meter per second. Finding the frictional head loss in pipe, which is HFS plus HFD equal to 4FLV square divided by D into 2G. Substituting the values 4 into 0.01 into 100 into 2.49 square divided by 0.16 into 2 into 9.81. We get the value 7.9 meter as a friction head loss in our pipe. To find the magnometric head, the equation is Hm equal to Hs plus Hd, that is our height, plus Hfs plus Hfd, that is our frictional loss, plus Vd square divided by 2g. Substituting the values, height equal to 15 plus our frictional loss is 7.9 plus Vd square, our velocity is 2.49 square divided by 2 into the gravitational constant 9.81. By calculation, we get the value magnometric head as 23.22 meter. The equation for overall efficiency eta 0 equal to Whm divided by 1000 whole divided by Sp, that is equal to rho into G into Q into Hm divided by 1000 into Sp. So we have Sp, which is the required power to drive our centrifugal pump, equal to rho G into Q into Hm divided by 1000 into efficiency. Substituting the values, we get the required power equal to 1000 into 9.81 into 0.05 into 23.22 the whole divided by 1000 into 0.6. After calculation, we get the value 18.98 kilowatt as the required power to drive our centrifugal pump. So that's the end of this video. Thank you.